Então, com isso, eu gostaria de chamar o professor de Vriend, da Universidade de Delft, Netherlands, para uma palestra sobre Building with Nature in the Netherlands.
Yeah, thank you. My talk will be somehow equivalent to Joe's, be it that we are talking about what we are doing in the Netherlands now. And the Netherlands is, of course, a totally different country from the United States. It's an awful lot smaller, so you have to put everything back to our scale. And then you will see that also in the Netherlands, building with nature is really picking up. Talk about what it is, why we do it, whether it appeals to people in our country, what the way of working is, etc., etc. You will see it coming by. No? Yeah. No, that's back. That's forward. I'm learning. What is it? So what is the Building with Nature concept? In the background you will see pictures from Building with Nature projects. This is a coastal maintenance project where we try highly concentrated local massive nourishments instead of distributed nourishments all over the place. I come back to that particular project later. So Building with Nature is about infrastructure development, especially hydraulic engineering infrastructure development. And most of it is actually what a good engineer always does. So he works not against nature, but with nature, because that's cheaper. But in order to do so, you have to understand the system's functioning. So you have to understand how the system works. What we do more than traditionally is make use of the dynamics of nature, so try to use nature, not only to comply with nature and fit into it, but also use it. And by doing so, creating new opportunities for nature. So that's an additional step to, let's say, traditional engineering, more or less like Joe described. And if you're lucky, you can let nature do part of the work. And that's, of course, very cheap. I have to say, in addition, that I'm advertising Building with Nature and the concept, but it's not a panacea. It's not good for everything. There are cases where Building with Nature doesn't work. So we have to remain critical about what we are doing. This is not a church we are talking about. We are talking about being clever. So, bringing it all together, you could say infra helps nature and nature helps infra. Which means that you don't build straight dikes, but try to include nature in the flood defense system, a very important issue in Holland. Here too, and the lower panel is not a dream. We are building it at this very moment. So it will be, you can see it I think in a few months from now. Why do we do it? There's a lot of reasons. We live in a changing environment, and not only climate is changing because everybody is talking about that, but there's a lot more changing society, economy, also worldwide economy, technology. And if you look forward 100 years, it's also worthwhile to look back 100 years and see what changed in the last 100 years, so that you can imagine what changes you have to take into account if you look forward. And it has been said already, the status quo is not sustainable. We have to keep on working on it, work ever harder sometimes if we work against nature. There is demand for new infrastructure, especially in countries like Brazil. And there is a need for adaptability and sustainability. Adaptability because you build for a long time and maybe the use of that facility changes over that time, so that it has to be adaptable to other functions or to other conditions, and it has to be sustainable, of course. Also, there is an economic argument, money counts of course, that monofunctionality, which we were accustomed to in traditional engineering, no longer works. We cannot afford it anymore. So, if we spend public money to an infrastructure, it has to have as many functions as possible. Nature, of course, is a point of concern. It has been said many times already. We have degradation, we have loss of area, don't forget that. Loss of diversity, loss of habitat. So that too is a call for sustainability. And of course then you say, why don't we let nature profit from the strongest drivers we have, economy and welfare and well-being? Another argument is that we accumulate ever more knowledge, know ever more about the systems we are working in, and there is a call to make better use of that knowledge and better integrate that knowledge. It's no longer, the problems are not monodisciplinary anymore, so we have to collaborate between disciplines. And we have to bridge the gap between research and practice. That's also a common problem in many countries. Academia is doing its work and it's writing its papers and it's making its publications, and the results are of no use to practice unless you do a lot of additional work. We'll come back to that on Friday. Moreover, legislation is often inadequate, and that's of course a kind of cowardice argument, but it is true. A lot of legislation, especially in Europe, is about preserving the state of the ecosystem. And that's against nature, because nature is dynamic by definition. So you have to respect the dynamic character of nature, also in legislation. So there's a lot of more work to be done, a lot more to be understood about the ecosystem functioning in order to be able to make that legislation at all. And for many of the works we are doing, and engineering works are necessary, the norms are not really realistic. Sometimes they're simply copied from elsewhere in the world. The famous example is the concentration limitations of dredging works, which are all based on what happened in Denmark, and which are applied all over the world, which doesn't make sense, of course, because every location is different. So there again, you need more knowledge, better tools, more insight in order to do better. The question is, does it appeal? So you can have a good case, you can have good arguments, but if it doesn't appeal, you don't get through. And I have indirect evidence here. These are the locations in the Netherlands where at this very moment building with nature type projects are going on. And although it's not the number of the United States, if you project it onto the scale of the Netherlands, it's quite a lot. So it does appeal to people. Apparently people in practice are willing to adopt the concept and work with it. Another evidence is that the European Commission has come up with its green infrastructure document, calling for working with nature more in general. So building with nature is actually a subset of working with nature, right? So European Commission, which is a very strong driver of developments of innovation in Europe, they come up with a call for working with nature. The Army Corps of Engineers, you've heard Joe's talk a minute ago. Piank, you've heard Tito's talk a minute ago. So there's many organizations which adopt this concept and say, well, we cannot go on like we did before, we have to do it differently. What does this mean for the way of working? We have to be interdisciplinary. Because, as I said, the problems are not disciplinary anymore. They are not about one discipline. They are much more complicated, much more complex, and certainly if you want multifunctionality, you are in the domain of interdisciplinarity. Interdisciplinarity meaning that you have to jointly invent new things, not have a problem, tear it to parts, go home, do your own disciplinary thing, and then bring it together again. No, you have to sit together and work together, bringing in your own discipline, but sort of merging it in the process. So it's a continuum, it's not separate zones. I will go into a number of examples from the Netherlands or what the Dutch are doing. And here we have this mega nourishment. The idea was that at the moment we maintain the Holland coast, a sandy coast, with nourishments. So soft engineering, that has been adopted a long time ago already, back in the 1990s. But we do that with small nourishments whenever it's needed. So we defined a coastline, a sort of setback line, and the coast may not withdraw behind that line. And subsequently, whenever it does, we nourish the coast with small amounts. That means that every time you do so, you disturb the coastal ecosystem, because you deposit sand there. And the return time of these small-scale nourishments is about 5 years, which is about the restoration time of the ecosystem. So the ecosystem is in a permanent state of disturbance due to this practice. We said, no, let's concentrate the efforts, let's concentrate the disturbance too. So let's make one big disturbance and give the system the opportunity to recover. So we did the experiment on the Holland coast with 20 million cubic meters, or 20 million plus, which was put at one time on the foreshore. And the idea is that the natural processes distribute that sand along shore, so it's a maintenance measure. We don't aspire to maintain the system as it is now. It is allowed to distribute along shore, and at a certain point in time it will be gone, and the whole shoreline will have come forward a few tens of meters. So we started that experiment in 2011, and at the left panel you see the original situation. On the right panel you see what nature has done to that. Of course, it immediately has reshaped the thing in what it likes, the sort of clockwise shape, and is now in the process of distributing the whole thing. In the meantime, you get juvenile dune formation, you get new vegetation in the lagoon. There is breeding ground for fish. There's a lot of recreation there. It's a kite surfer's paradise. So a lot of other things are happening there, and that was exactly the intention. Another one, I simply go around a number of environments we are working in, is coastal restoration by especially mangrove coasts. So mangrove is a good coastal defense system if you properly maintain it. Another one, which has also been mentioned by Joe, was coral, or coral and seagrass, which have a very interesting interaction too, which we applied in Singapore and are testing further in Indonesia. This is an example of what can happen if you remove the coastal protection, a natural coastal protection like mangrove. So this is in Demak, Indonesia, where they removed the mangrove for fish ponds. And at a certain moment the fish ponds were abandoned because they were too polluted, and the companies went elsewhere, and they no longer maintained it, and the consequence was very, very heavy coastal erosion, which was aggravated by subsidence there too, because of groundwater subtraction. So that is really kilometers coastal retreat in a few years. And you can prevent that by maintaining your mangrove coast, or you can restore it by rebuilding the mangrove coast, which is not a trivial task, by the way. You have to very well understand what are the necessary conditions, otherwise it simply doesn't work. The estuarine environment has already been mentioned. Oyster reefs, very interesting concept because it provides habitat to all sorts of other species. And it is dynamic, it is adaptable. We use that for the protection of the shoals in the eastern scheldt, which are eroding. Another thing we are doing to those shoals, to those eroding shoals, is simply nourish the tops of them. What you see in the right panel is an experimental nourishment, where we investigated whether the nourishment would disappear faster than the ecosystem would recover. The answer is positive to the ecosystem. The ecosystem recovered faster than that the nourishment disappeared. So it's a viable option. Oyster reefs also in other countries. I think this one is from the United States, Joe. Is that true? But we are also applying them in Bangladesh, for instance, for coastal protection. A quite interesting one is the marine environment, because if you maintain a coast with sand, you have to find that sand somewhere. And we draw that from the North Sea, which is full of sand thanks to the ancient Rhine. But you create mining pits, sand mining pits, borrow pits. And until some time ago, the law required that the bottom of that borrow pit was finished flat, horizontal. And then on the basis of some research in the European framework, we found out that a seabed which is corrugated, which has bars and ridges, is environmentally much richer than a flat seabed. So we said, why make a flat seabed in those borrow pits? Let's make it corrugated and leave some of these ridges there and see how that works out for the ecosystem. And already after a few years, we started this experiment 2 years ago or 3 years ago. You can see that the amount of fish in that borrow pit is 5 times as high as in another reference pit. So apparently this is an attractive place for fish to be, and that also indicates that it's an attractive place for the other species which the fish feed on. Tropical marine environment, where we have gone into dredging practice which used to be very much focused on the production of fines, so the turbidity plumes. And we said, well, let's not start with the dredging operation and the turbidity produced, but let's start from the ecosystem that is harmed by the turbidity and see how much it can have. And if we produce too much for that ecosystem, then we stop the operation or we reduce the operation or do something. So that starts with species response curves, which indicate how long a species can stand which pressure, and you can work that out to a sort of support system for dredging operations. Fluvial environment, Netherlands is a testbed for fluvial projects. One of the big programs is called Room for the River. We had problems with the flood conveyance of our rivers, and instead of dredging them deeper, we made them wider. Because if you make them wider, that has better effects on the flood wave properties than making it deeper. So at a lot of places we created side channels or we laid back the dikes. Initially there was a lot of opposition against that because you changed an existing situation, right? And people don't like that. But after some time they began to see the opportunities, and this is an example where this worked out very, very fine. So this is a side channel near the city of Nijmegen, and at a certain moment people discovered, oh, if I go live on that island. My house is a lot more worth than if I live in the city, and it is much more interesting. There's a lot of additional functions like recreation, like connection with the new city development at the other side of the river. Well, everybody's happy with it at the moment. This fluvial environment is much more tricky than you might think at the first sight. There's a number of worldwide river problems which not directly have to do with flood protection, but which indirectly do. One striking example is massive water abstraction. So in many countries there's a lack of fresh water, good water, and the rivers provide that, and it's very tempting to take it out of the river and say, okay, then the river goes on with a bit less water. But if it has a bit less water, it has a bit less sediment transport port capacity, unless it changes its slope. So what that river does in the long run is change its slope, make it become steeper. But there is one fixed point in the river, that is where it debouches into the sea. So this river starts tilting around this point near the sea. And that means that at a few hundred kilometers away from the sea, that the river comes up with its bed meters and meters higher and meters above the surrounding area. This is called a suspended river. And you can imagine that if the dikes of that river fail, that then you have a big problem. And the picture here shows the Indus in 2010, which took a 500-kilometer detour due to this effect. So major problems, simply because people didn't realize that this river had come up meters above the surrounding environment. You see that in the lower panel. Another effect of that is that the river, in order to build up its slope, needs sediment. So it stores sediment, and that sediment doesn't go to the coast. So you get coastal erosion, because the coast is accustomed to a certain supply of sediment, and if it doesn't come anymore, then it retreats. So that's a secondary effect which people don't couple to the water abstraction, of course. That's too much asked. So my message here is, do not manage only river water, but also river sediment, because otherwise you get into trouble. And the same actually goes, I will not go into that, for nutrients and contaminants. Another worldwide problem, of course, is dam building. Dam building which affects the flow regime, and if the flow regime changes, then the sediment transport capacity changes, usually is reduced, so there is less sediment coming to the estuaries and the coast, coastal erosion, estuarine degradation, everything happens. And there too, the dam or the reservoir traps nutrients together with the fine sediments. These nutrients don't go into the coastal zone, so you get degradation of the ecosystem in the coastal zone. Very indirect, but the cause is clear. So the message here is, again, do not manage only the water, but also the sediment and the nutrients and the contaminants. A third problem is, of course, river pollution. The top panel is from a river in Brazil, where there was poisonous foam developing. The lower one is from Thai Lake in China, and what this guy is pouring is not paint, but that is water with algae. The algae concentration is so high that it looks like paint. So this is simply eutrophication of the lake. So there again, sediment, especially fine sediment, carries other things like contaminants, nutrients, may lead to eutrophication or contamination, and you have to do something about it. Quite interesting is building with nature in the urban environment. In the urban environment there's little space, of course, so you cannot do the space-demanding things that I showed you a minute ago. But still you can in the framework of city revitalization or flood protection or whatever you need there, you can do things. In the top panel you see a plan for, it's called New Meadowlands. It's at the other side of the Hudson River in New York. So the part at the right side is Manhattan. And in the lower panel you see a plan for actually climate adaptation in Rotterdam, where there's also a lot of green initiatives taking place. Small scale, but together they constitute a major effect. I'm doing time-wise, 5 minutes. Okay, then I skip these ones. In the first phase of the Building with Nature program in the Netherlands, we said we want to be open about our knowledge and our data and our models. So we created a wiki, and that wiki can be addressed through our website, in which we described everything we learned, and that's openly accessible. Everybody can go into it. So if you want to know what we learned, the lessons we learned, the projects we did, the tools we used, tutorials, there are even tutorials, you can go to that guideline. In that guideline is also a knowledge base with building blocks, so elements you can use in order to compose a building with nature solution, tools, pilot and case descriptions, and pages with background knowledge. In the second phase, in the first phase we had a subsidy, so we could do a lot of things on our own and do a lot of experiments and pilot cases in order to find out whether building with nature would work. In the second phase we have no more subsidy, so we have to live on projects and the willingness of these projects to adopt the building with nature concept. Much more difficult to get your money, but also quite rewarding if you get it. And you saw on the map of the Netherlands that there is a lot of willingness to use the building with nature concept and to call you in. Would building with nature work in Brazil? We have a growing economy, demand for transport, it has been said, port development, green ports. Green ports is at this moment still a lot about operation, but you can also extend that to engineering, building of new ports in such a way that they are as green as possible. There is a growing agricultural production, including bioenergy, so demand for water, so ground and surface water extraction, also from rivers. So there comes my point, sustainable river management requires not only water management but also sediment management. You have growing mega cities like Rio, which now has 10 million. In the future it goes up to 30, I expect. So there is a demand for quality of life, there's also an increasing quality of life if your economy picks up. Your water footprint is bound to increase, you are going to eat more meat with much more water footprint, etc. You need more energy, so cooling, you need stormwater management, well, all sorts of things that are required in big cities and which can be solved to a large extent with green solutions. Water pollution, here's a picture from Brazil as well. So you get environmental degradation, loss of natural resources. You could have eaten all this fish. So that requires sustainable water resources management, and there again, ample opportunities for green solutions. Water quality, so contamination, eutrophication, oligotrophy, all things which call for sustainable nutrient management. And remember, nutrients don't have too many and don't have too little. If you have too little, everything dies. If you have too many, then one species survives and dies, kills everything else, the algae. So the message is always understand how the system functions and find the optimum solution, taking a life cycle perspective, a long-term perspective. If you take a short-term perspective, will it work tomorrow and will it be the cheapest solution for tomorrow? You often end up with traditional engineering. But if you take the long-term perspective, if you account for the additional benefits also in the longer run, then green solutions often are the cheapest. So my conclusion is that in a growing economy like Brazil's, that the opportunities for win-win relations between infrastructure and nature are excellent, but you have to make sure that you have sufficient knowledge, expertise, and acquaintance with the local ecosystem in order to be successful. Thank you very much.